Okay, what we're going to do now is we're going to talk about different types of meters here that we're going to use in class, and some of the benefits and drawbacks of each. So these meters should look familiar from the 108, 109 class. So the first meter that we'll look at here will be the Simpson's 260. So now what this is this will be the analog meter, and it's a little bit different than the auto-ranging digital meters. There's a variety of different settings that you have to work with here in order to get this to read correctly. So, for example, this would read just like a normal meter. You could read resistance on it. You could check for continuity. It's not going to tone like another meter will that I'll show you. It is going to be able to read current, DC current. It can't read AC current. We would need a clamp-on meter to read AC current, and we don't use this meter to read AC current. You could read voltage, obviously, with it. And so it has the scale here that you learn how to read based on what the setting is right here. If you remember from class, for example, if you wanted to read something that was on 50 volts, 50, you would have to look over here on the voltage, and you'd have to get the scale, which was here in the middle. So 50, 40, 30, 20, 10, 0. And then depending on where it came up, you'd have to determine what the divisions were here. And then you could do that. So here's 10 volts, for example. If I was reading 10 volts, I could read on the 10 scale. And it reads pretty simple. There's 1, 2, 3, 4, 5, 6. And so how much are these little increments? It looks probably 0.2, 2.4, 2.6, 2.8, 3. So 0.2 increments. So you would have to determine what the increments were, and if you needed to multiply them on the side here to match what you had selected there. And that was what you had learned in 108, 109 using this. But we'll be using it to measure voltage, okay? And we'll also be using it to measure resistance. So just remember, if you're measuring resistance, you would have to get the meter set up, turned on. And here we'd go to R of 100 ohms. And then what you would do is you would touch the leads together here like this. And that causes the meter to go up. Notice it's not on the 0. So then you would turn the 0 ohms down until that red 0, and then you would have it calibrated to read resistance there, okay? So what are the benefits and the drawbacks? Well, the drawback is that this is a type 2 meter, which means that you can't bring it into a facility that has 3-phase. It's maybe more of a meter that would be used in a laboratory situation for looking, for example, one thing that's good at is measuring a signal that's varying back and forth. So if you had a DC voltage that was dropping very fast, you could see that this rising, dropping fast, you would see this needle moving back and forth, okay? Or checking a capacitor. If you plug in the capacitor, you would see the voltage, and it would slowly degrade as the capacitor died. If you had a digital meter, the meter might just be jumping around so fast here with readings that you would never really be able to figure out what was going on, whereas the needle here will show you those readings, okay? Another drawback is it is kind of hard to read here. You have to be trained on it to understand the scales and know how to figure out your increments and everything like that. But it's pretty basic meter, so therefore, hopefully you can't break it. What you might do is you might peg it, because if you don't, when you're trying to measure something, let's say you're going to try and measure an open would have theoretically a resistance of infinite, so you would have to start at the highest scale for that and then start dialing it down as you were checking your item if you weren't sure what the resistance was, okay? Whereas if you were checking a short, you would expect that there would be no resistance, and so you would start at a low level, because you would hope that you'd be getting 0, and then you would dial it up if you were getting resistance. So you'd have to work on the scale here, and then you would try and get on the scale here that gave you the best resolution up here so that your answer was as close to possible. So that is the Simpsons meter that we use here. Okay, so the next one. The next one is the digital voltmeter here. And what this is good for is, really good for, is measuring continuity and voltage and resistance. It also measures current. It's not the best. It'll measure current, but it might not be the best way to measure current. We'll look at that in a minute, depending on what accuracy you want. But it'll measure current pretty good. Like we said, the Simpsons has its strength. It's good for resistance and voltage. This one's the same, add continuity, and it is easier to measure a current than the Simpsons. So what this is really good for is like continuity. So if you were going to check to see if something was a conductor or was it closed, you could set it to continuity there, and when you touch the leads, you get the tone. So that's really good, really easy to check if switches are working, or if the circuit's designed and wired up correctly with continuity. It's also good for measuring resistance. You can just set it to resistance there, and when you touch your leads to a load, what it does is it will auto range. It'll come in here and it'll auto range, and it'll tell you what the resistance is. What's difficult to keep in mind is that it might have a number here like an M or a K showing that you need to multiply the number by 1,000 or 1,000,000. So similar to the Simpsons, you have to understand the ranging of it and the scaling of it to be sure that you get a good read. Voltage is easy, same thing. You would put it on AC voltage, and you would wire this in parallel, and it would auto range. There's a hold feature here that the voltage was varying. You could hold it. Same with DC voltage there. But like I said, the Simpsons, if you had a pulse that was pulsing very fast voltage, you wouldn't see it here. This would just keep jumping around. And even if you did have the hold on, if it was a quick pulse of, let's say, 50 milliseconds or something like that, this would never even hold. So the Simpsons would be better for that. But typically, a lot of times we don't have pulsing voltages that are fluctuating very, very rapidly. And, these could get what you want. Here's a millivolts if you're measuring something small and you wanted even a better resolution. And then this also does amperage. Like I said, it's great for measuring amperage, but a clamp-on meter might be safer because on this one you have to rewire this so that it becomes in series and becomes part of the circuit. And once you wire this in series and it becomes part of the circuit, you have to be sure that you do have a load, because otherwise the meter will become a load, and the meter is not really meant to become a load. It's not a load. We do not want to turn the meter on with the circuit, otherwise you will blow up the internal fuse in here. But this readily and easily measures AC and DC amperage, okay? And then here's a 300 mA, which will give you, if you're measuring smaller amperages, that you would start by, maybe using some Ohm's law to get you in the idea of where you might be wanting the setting to be here, up to 10 amps or 300 mA to get a better reading. Your calculations will get you close on that. So this is a digital multimeter, and it's a type 3 meter, okay? And so finally, the last meter that we would look at would be the T5 here. It's kind of like a little bit of a clamp-on meter. So what this is it's pretty good for all those things as well. So what it does, if you want to check continuity, you can set it to continuity, and you would get a tone there. Okay, let me bring that up there so we can see what it says. We would get a tone. It's basically saying that I have continuity. The multimeter is a little bit better because it does have a separate resistance and a separate continuity setting, okay? And so what these are set up is for, this one is going to tone when you have resistance for like under 1,000 ohms, when a lot of times your tone, you're looking for continuity. And so you might be confused of how you would find continuity versus resistance. Whereas the other meter here, you can just set it to continuity and look for a conductor or a closed switch or an open switch versus checking a load with resistance, okay? Because this one will be maybe at 200 ohms or less. So just remember, if you're checking a load, you're checking resistance, and if you're checking for continuity or closed circuit, you're checking for continuity. Whereas this one puts both functions into one. So that's okay. It does check voltage, AC or DC. So pretty regularly, you can just touch the leads to AC and DC and it'll auto range. So the digital multimeter might be give you a little more accuracy here because you're able to go to a smaller setting here of 300 millivolts, which is going to give you a few more decimals, where this is going to give you kind of a gross reading on that, okay? And then what this does, it does amperage, and it will do AC amperage, okay? This one is not, this one here, you can do AC or DC, and remember, it'll take 10 amps, but it's also got the 300 milliamp. If you have some calculations that are under 0.3 amps, it'll give you more decimals and a little more accuracy. That's whereas this one here is going to give you kind of a gross amperage reading. And so the benefit of this one, though, with measuring amperage, is you don't need to make it part of the circuit. Like I showed you on this one here, you had to put it in series with a circuit, and you risk blowing the meter up. This meter has got a sensor on it, so let's say this was your wire right here. You just stick the meter where the wire is, and there's current flowing through the wire, it will read right there. So that is a great benefit of that. That's probably what the strongest of this is reading AC current, okay? And so once again, this is a Cat 3 and Cat 4 meter, which we'll go over a little bit later. So those are some examples of the meters that we use in this class and the strengths and the weaknesses.